This is section 3.3, power functions and polynomial functions, day 1. So let's start out with power functions. A power function is a single term that is the product of a real number and a variable raised to a real number. So it's number times x to the something. Make sure that something is a real number. So which of these functions are power functions? So this first one, f of x equals 1, well, that we can technically write as 1 times x to the 0 because we know x to the 0 is just 1 and it doesn't change anything. Then we have a constant multiplied by x to the power of a real number, so that one is good. Second one, f of x equals x. Well, we know that there's a hidden 1 here, and that's like there's a 1 in front here, so we have a constant times an x to this real number. Good. X squared and x cubed work the exact same way as f of x equals x. Looking here, 1 over x, if we use our rules of exponents, that's the same thing as x to the negative 1. So that one works because negative 1's a real number. Same thing with this one, it'd be x to the negative 2. That's a real number, that's fine. And then our radical ones. So remember, the square root of x, another property of exponents, is that's the same thing as x to the 1/2. Well, 1/2 is a real number, so this one works. This one would be x to the 1/3, which also works. So these are all examples of power functions. Then we're going to talk about end behavior of power functions. So what happens on the left side, what happens on the right side. So there are 4 different possibilities. So you can take a look here. So even powers versus odd powers. So if it's like x squared or versus like x cubed, even versus odd. And then if our number in front is positive or negative. Basic thing to know, even powers, they're either both ends are going to go in the same direction, so they're either both going to go up or they're both going to go down forever. Odd power functions, one's going to go up, one's going to go down. It just depends on whether k is positive or negative to tell which one goes up and which one goes down. So let's use this chart to try to figure out the end behavior of each function. So looking at x to the 4th, I know that x to the 4th, we have a positive coefficient or constant because it's a 1, and it's an even power, so we're here in the middle. So as x approaches infinity, y also approaches infinity. So as x gets bigger and bigger and bigger, y gets bigger and bigger. And then as x approaches negative infinity, so gets smaller and smaller and smaller, y still approaches infinity, which you can see is labeled right there. All right, next one, f of x equals negative x to the 9th. We have a negative constant because we have negative 1 in front, and an odd power because it's to the 9th. So our answer would be right here. As x approaches negative infinity, f of x, or y, approaches positive infinity. And as x approaches positive infinity, y approaches negative infinity. And last example of this type, negative 5x to the 4th. So we have a negative constant and an even power, which puts us in this box. As x approaches negative infinity, y also approaches negative infinity. And as x approaches positive infinity, y also approaches negative infinity. So you're looking for this chart, and then what's written down at the bottom is going to be your answer. So these are going to be your answers for end behavior. You just have to pick which one it fits. Polynomial functions, we talk a little bit about polynomials back in Algebra 1. So they're functions. Exponents on variables must be positive integers. Okay, so remember, if we have a negative exponent, it puts it in the denominator, which we don't want. So we don't want any variables in the denominator. And then we also don't want fractions or decimals for our exponents, because remember, that's going to make it into a radical. So positive integers are our only options for exponents to make it a polynomial function. And then make sure the terms are in descending order. So the term with the highest exponent goes first, all the way down to a constant term. So which of the functions are polynomial functions? Well, let's simplify this first one. 2x cubed times 3x plus 4. Well, I know I can do this multiplication to get 6x to the 4th plus 4. I don't see any variables in the denominator. I don't see any radicals. That exponent is a positive integer, so this one works out. Looking at the next one, I can simplify by distributing in. So I have negative x cubed plus 4x. Once again, no radicals, no variables in the denominator. This exponent of 3 and this hidden exponent of 1 are positive integers, so this one works. And last one, 5 times the square root of x plus 2 is automatically a no, because we do not like that radical. And then characteristics of polynomials. So we talked about the end behavior before. Actually, we're not going to get to end behavior quite yet. So characteristics of polynomials, our leading term, when we have it written in descending order, so remember our exponents go like largest to smallest, our first term is called our leading term. The constant in front of the x in the leading term is called our leading coefficient. And then the exponent of our largest exponent is called our degree. So let's identify the degree, leading term, and leading coefficient. So I want to write these in descending order. So if I rearrange it, it's negative 4x cubed plus 2x squared plus 3. In this case, my degree is 3, because that's my largest exponent. Leading term is negative 4x cubed, and my leading coefficient is negative 4. All right, the next one is already written in descending order for us. So our degree is 5. Our leading term is 5t to the 5th. And then my leading coefficient is 5. And last one, let's rearrange. So this is the same thing as negative p cubed plus 6p minus 2. My degree is 3, because that's the highest exponent. My leading term is negative p squared, or p cubed, sorry. And my leading coefficient is negative 1, because remember, it's like there's a hidden 1 right here. Now talking about end behavior of polynomials, we want to look at the leading term, and then the end behavior follows that of the leading term. So if we're looking here at h of p, I'm looking at the leading term of negative p cubed. It has an odd power and a negative k, or a negative constant. So I would go back up to our handy chart. We have an odd power and a negative constant, so we would be in this box. So the end behavior is going to follow that of the leading term, so we can just forget about everything else when we're describing end behavior.